So I'm just going to go over the details of the different traps, and I'm going to draw them as best I can, given the iPad app that I'm using. So basically an anticline is when your layers are basically in an upfold like this. And so you would need a source rock. So in this particular case, I'm going to put shale right here because shale is a really good example of a source rock. So this is my source rock. Down here I could have anything. I'm just going to put sandstone there. So the source rock is where the kerogen goes through don't call me, diagenesis, catagenesis, and metagenesis. Hopefully it stops at catagenesis. The petroleum is going to come out of the source rock and go into a reservoir rock. This reservoir rock could be dolomite, it could be limestone, it could be conglomerate, it could be sandstone. I'm going to go with sandstone. So that's going to be your reservoir rock. And then it all needs to get capped off by something. So I'm going to go with a rock called shale. Shale is an example of a cap rock. It's very impermeable and nothing can kind of get out of it. Now it is potential that, you know, all of this could get basically buried in by anything. So in this particular case I'm going to have it all to get buried in by sandstone. Now, so we have all that we need. We have our trap, we have our source rock, we have our reservoir rock, and our cap rock. Here is the trap in this particular location right here. So any petroleum that comes into the reservoir rock, which is the sponge, is going to move up and is going to build up here. So you get a layer of gas, and then you get a layer of oil, and then your water would be below. So I'll just kind of shade in this little area right here. So this would probably be your oil, and just above it would be your gas, and then below it would probably be your water. So that would be your gas over your oil and your oil over your water. A good drill location would be right there. Moving on to fault trap. Now it can be a different kind of fault trap. So what I'm going to do is I'm going to draw my fault first. And so I'll draw my fault like this. So I'm going to need a layer, and so I'll make this here to be shale, and this here will be shale, and then I'll put on a layer of sandstone and a layer of sandstone. So this is going to be sandstone like this, and then I'm going to keep it really simple for the purpose of this video. So I'll put shale over the top like this, and then shale over the top. So here's the shale, just like this. Okay. So basically down here we have shale. So shale is going to be our source rock. This is where the kerogen gets buried and undergoes maturation. Any petroleum would leak out into the reservoir rock. Okay, so the reservoir rock is in this case the sandstone, could be conglomerate, dolomite, or limestone. And then basically it gets sealed off because this is cap rock, it's shale, and this is cap rock, it's shale. So any petroleum in the area can't get out through here or here, so it builds up in this area right here. So this would be the fault trap. So you'd have your drill rig right here, and you would drill down into the trap. Okay, if it wasn't for the fault, the sandstone wouldn't be shifted. And so because it is shifted now by the fault, this sandstone in this location is shifted up against shale over here and shale over here, so it can't get out. And you drill down through here and you go right into the petroleum, which is gas or oil. In this particular case, if I drew my line down through, this side is the hanging wall, this side is the footwall. So the hanging wall is moved down in relation to the footwall, so this would be a normal fault trap, petroleum trap. In terms of a salt dome trap, salt basically forms domes on the bottom of the sea or the bottom of the ocean, and it's important that you understand that salt is very impermeable and nothing can get through it. So what you'll have is you'll have sedimentary layers that basically get deposited over the salt like that. Okay, so this would be like a salt dome trap. Let's go with our shale down here. So this shale would be the source rock, and I'm just going to use sand for my reservoir rock because it's easier for me to draw on the particular iPad. Okay, so this here is a reservoir rock, nice spongy sandstone with high porosity and high permeability, and we're going to go with shale right here because we need shale to be a good cap rock because shale is very, very impermeable. Remember that the salt is also acting as a cap rock. If any petroleum comes out of this source rock and goes into the reservoir rock, that would make this particular area in here where I'm shading a salt dome trap. Similarly, you could also have a salt dome trap over on this side, okay? Now this here could be buried by anything, could be shale or limestone. I'm just going to quickly shade it in because it doesn't matter. So you'd put your drill rig here, and that would be your salt dome trap. You could also directionally drill, and you could drill there, or you could put your rig over here and you could drill again. But in this particular diagram, there are two different traps. In terms of stratigraphic trap, there's something about the sedimentary layers basically that provides a trap. A limestone reef is the one that we have here. So if we have a limestone reef, so here's a reef, and a reef is something that is alive, it's biological, and does photosynthesis and basically grows up in oceans. So think of the Great Barrier Reef in Australia, or reefs like places like Jamaica, whatever. Let's just say if this layer down here below the reef was shale, so shale would be a source rock. So if there was any organic matter in that source rock, it could start going through maturity and don't call me. And then the reef is either going to be made of limestone or dolomite, both of which serves as a really good reservoir rock. Let's pretend that the reef basically gets buried by mud, and the mud gets lithified and forms shale, and then you could have anything else above it. So I'll put a layer of shale and then a layer of sandstone. In this particular case, the shale right here and all through here and all through here acts as the cap rock. So there's your cap rock, there's your cap rock, there's your cap rock. Down here you get your source rock, and the reef is a reservoir. Here in the top of the reef, it is possible to get gas over oil over water, which is your GOW. Okay, and that's based on density, because gas got a lower density than oil, and oil got a lower density than water. So in the limestone reef trap, you would actually drill right there. So I just have a blank page put here, and my reason for a blank page because I wanted to show you another type of stratigraphic trap. So let's pretend that we have a squiggle line, which is a nonconformity, and I'm just going to put two layers above the nonconformity. I'm going to go with a layer of shale, which is going to eventually be my cap rock, and I'll just go with a layer of sandstone, okay, which is completely irrelevant. And then we're going to have layers beneath here. So I'll go with shale over here. And this shale is going to serve as your source rock. Actually, yeah, I'm going to call this the cap rock instead. And then right here we're going to have our layer of sandstone. And over here I'm going to have a layer of shale again. Okay, just keeping my rock symbols nice and simple. So if this here is the source rock, the organic matter is going to mature, and the petroleum is going to come out of the source rock and is going to go into this sandstone here, which is a nice spongy reservoir rock. It can't get out over here because it's a cap rock. It can't get out over here because it's a cap rock. It can't get out over here because it's a cap rock / source rock. So that would make this area right here the trap. So you'd get your gas in the top, and then your oil, and then your water. So this would be your gas, this would be your oil, this would be your water. Okay, it's a stratigraphic trap of the type onconformity, and in this case, here's your squiggle line, which is the onconformity, and it's an angular onconformity. You would drill down through here, and that would be a producing whale.